Hello, I'm Matthias Guimau, Network Solution Engineer. Today, with Slaven, Senior Network Solution Architect at Alcatel-Lucent Enterprise, we are excited to demonstrate the integration and management of ALE OmniSwitch with Nokia NSP management platform. Nokia NSP is a widely used management platform employed by many customers to efficiently manage and monitor their networks. In this video, we'll showcase how our collaboration with Nokia has resulted in the creation of a single pane of glass management platform that will help you day-to-day monitoring and operation. Let me outline the agenda of today's presentation. Slaven will kick things off with an overview of NSP, its various domains of application, and delve into the detail of our single pane of glass NMS solution for end-to-end management. Following that, he will discuss the integration of OmniSwitch into NSP. Then, I will take over with a demonstration of NSP in action, managing Nokia ALE networks seamlessly. Finally, I'll conclude with some key takeaways. Over to you, Slaven.
Thank you very much, Matthias, for the introduction. As you already know, Nokia and ALE have joined forces to construct robust, integrated critical mission networks, leveraging a combination of their product portfolios. In this video, we will demonstrate how you can efficiently manage AOS products within these unified networks using Network Service Platform NSP and its component NFMP. But before we dive in, let's briefly explore what the Network Service Platform provides and how it can improve your network management. NSP serves as a comprehensive platform for managing and overseeing transport networks spanning various domains and technologies across multi-vendor networks. This powerful platform offers automation capabilities for configuring networking devices and expediting the delivery of transport services. It incorporates SDN control to optimize network utilization and traffic engineering, while also providing dynamic assurance to operate the network with optimal performance and reliability. When it comes to various industries relying on mission-critical networks, the demand for end-to-end automation in network operations is paramount. Whether managing IP/MPLS core infrastructure from Nokia or Ethernet edge elements and services from ALE, customers across sectors desire for streamlined processes. Manual interventions often result in errors and delays, impeding cost-effective and timely network deployment. By seamlessly integrating ALE's proprietary extensions into Nokia's Network Service Platform network management system, customers can now consolidate and automate their operations effortlessly. This integration offers a unified interface, providing a complete view of the entire network landscape and significantly boosting overall operational efficiency. Through the integration of selected OmniSwitch network elements into NSP and FMP application, network administrators gain the ability during deployment to configure OmniSwitches down to port-level details, enclosing features such as power over Ethernet, port mobility, and learned port security. Moreover, NFMP empowers administrators to provision end-to-end services by configuring multiple Layer 2 and Layer 3 protocols, quality of service, access control list, and security authentication parameters. Additionally, NFMP facilitates network monitoring by offering comprehensive reporting on critical statistics and performance parameters, crucial for troubleshooting in mission-critical end-to-end networks. Now let's go back to Matthias, who will show you a glimpse into the capabilities mentioned above.
Thanks, Slaven. Before diving in a demonstration, let's have a look at the physical architecture that we are going to use. We have two 7750 SR1 with an IP/MPLS network underlay already running, with LDP to distribute the labels and OSPF to distribute the routes. This configuration can be done from NSP, but we won't go in the detail of that in this demo. Here we have only two PEs, but we can imagine that we operate a huge MPLS network with P and PEs. And we have two OmniSwitch 6865 as access ruggedized switch. Let's imagine that we want to deploy a L2 connectivity between two sites over an MPLS network, with one site connected to S1 and the second site connected to S2. We will begin by the configuration of a link aggregation with LACP between PE2 and S2. The one between P1 and S1 is already configured. Then we will create a VPLS on the MPLS network which corresponds to a L2 service, and we will connect it to a VLAN on each OmniSwitch using a service access port and 802.1q tagging. Finally, we will configure IP interfaces that will simulate two CPEs that would be connected to the OmniSwitches. Here we are on NSP NFMP. On the right of the screen, we can see the physical architecture of the network that has been discovered automatically. Let's proceed with the configuration of the link AG on PE2. We need to go in the logical groups of PE2 and create a lag. We want it to be the lag 2, and we will put the description to S2. We put the mode as access encapsulation 802.1q, and we click next until the LACP part. We enable LACP in mode active. Next, we can add the physical port, which is 11C2. And we can finish the creation. Here, the link appears red as the link is not configured on the other side. Let's do it. We click on S2, logical groups again, and we can create the link AG. We put the lag ID to 2 again, the interface as access, and the encapsulation in 802.1q. We will have only one physical port in this lag, so we can select 1, and we call it 2PE2. We put dynamic, click next. Here, we can put the actor administrative key to 2 and finish. Then we need to assign the physical port to the lag. We select the port 115 and we put the administrative key to 2. Now we can resync the PE2 and the link should become green. During the synchronization, we can begin the creation of the VPLS, which will be our L2 service over MPLS. Let's go in Manage Services. We can create a VPLS. We select the default customer. We will put the service ID 10 and we will call it Data Customer X. Then we can add the two PEs. For each one, we will create the access interface, which is the lag that go to the OmniSwitch. So for P1, we select lag 2. We put the encap value to 10, which will have to map with the VLAN ID on the OmniSwitch. Same for PE2. We select the lag 2 and put the encap value to 10. Then we can configure the spoke SDP, which connect the VPLS over the MPLS network. We can select the SDP that goes to P2, which is already configured. Same on PE2. We can select the SDP that goes to PE1, which is also already configured. And we can finish by applying the configuration on the nodes. And now all the links are green. Next, we can create the VLAN on the Omni switches. First, we need to create a VLAN groups for the Omni switch. And we can add S1 and S2. We apply the configuration. And we can go back in Manage and Services. This time, we will create the VLAN. We select the default customer again. We put the service ID to 10. And we name it Data Customer X like the VPS. In VLAN tab, we select the group that we just created. Then we can add the two Omni switch in the service. And for each one, we will add the lag that goes to the PEs. It is also here that we add the untagged interface that goes to the CPE, but we won't do it in this demo as we don't have any CPEs connected. We can select the lag2 that goes to the PE1, and we set the interface as tagged so that it maps with the encapsulation value of 10 configured on the PEs. We also add the lag2 on S2 that goes to PE2. And we finally apply the configuration. Lastly, we will add an L3 interface on the Omni switch to simulate the CPEs. We need to go in Routing. On S1, we can create the interface CPE1 Customer X Data. We can add a random IP address. I will put the address 10.0.0.0 with the net mask 31. And we'll select the VLAN Data Customer X. We will do the same on S2. We name the interface CPE2 Customer X Data. We put an IP address in the same network, 10.0.0.1 with the net mask 31. Next. And we finally select the VLAN Data Customer X. Let's have a look at S1 from CLI to check our configuration. We can see that the link ACK2 is configured and up. We have the VLAN 10 Data Customer X with link ACK2 tagged. And we have the IP interface CPE1. Let's try to ping CPE2. Yes, it works. If we show the MAC address table, we can see the MAC address of S2. Let's check on PE2. We can show the MAC address table of the service 10. And we can also see the MAC address of S2 connected on lag 2, as S2 is directly connected to PE2. Let's check the MAC address of S1. Here it is, ending by EF19. And we can see it on PE2 connected to the SDP, as S1 is connected to PE1. This is the end of the demo. Note that this is just an example of configuring combined networks with NSP. We can do much more. You can contact us for more info. And all this configuration can be easily automated using the North API of NSP. Let's conclude with some key takeaways. We hope you enjoyed this video showcasing capabilities of Nokia NSP, NFMP, NMS for managing combined mission-critical networks. At ALE, we are dedicated to continuously supporting the integration of selected upcoming OmniSwitches products and software releases from our portfolio. Our commitment aims to deliver the following benefits of a single NMS to our customer. Firstly, reduce CapEx and OpEx, simplifying implementation planning, deployment and upgrades of a unified NMS. Secondly, a unified, simple and comprehensive user interface for end-to-end solutions. And last but not least, automation of workflow, reducing effort and cost associated with deploying end-to-end solutions. Thank you for watching, and please don't hesitate to reach out to us if you have any question or require further information.